afternoon to of you, participants in society organizing chapters, auditors and participants of AIS digital program, participants from state and central government, user ministries and departments, participants from academic institutions and industries. A warm welcome to all of you for participating in this program conducted jointly by Indian Society of Remote Sensing and Indian Space Research Organization, the eve of the National Remote Sensing Day. The National Remote Sensing Day is celebrated every year on August 12th, to mark the birthday of Dr. Mishra, founder of space program. Today's program is being organized with an aim to popularize remote sensing based mapping applications and geospatial information. The use of geospatial data services becomes in programs, planning, monitoring, and making at different levels, national level, state level, district level, and even at panchayat level. Main and state have been to the geospatial information for effective governance and decentralized planning benefit and map. Technology is technology visualizing and analyzing all information. Citizen science through crowdsourcing is also an emerging new way of collecting, processing, and analyzing the geospatial data. In this workshop, we bring you a galaxy of eminent speakers from ISRO fraternity who will be sharing their experience and knowledge with you all. You will have a unique opportunity to listen to Secretary Department RS and former Secretary to Ministry of Earth Sciences, Scientific Secretary of ISRO, and ISRO Directors of Space Application Center, National Remote Sensing Center, and Northeast Space Application Center. In addition, selected demonstration will be made on geospatial products and services available as on today in various geoportals. There will also be a live panel discussion with experts who will discuss the challenges and provide way forward to fulfill the aim of this workshop. As major percentage of participants of today's program are students at UG and PG levels and also researchers, the students community can consider this exposure workshop as an opportunity to align their career due to increasing job perspectives within the country and as well as in abroad. While the researchers may look the geospatial technology providing phenomenal challenges that provide food for their analytical skills. I hope in all this exposure workshop will benefit one and all of you. I once again welcome you all to this workshop and thank you very much for your kind support.
My dear students, teachers, members of the Indian Society of Remote Sensing, ladies and gentlemen, my hearty greetings to all of you on the eve of the National Remote Sensing Day. I join Dr. Senthil Kumar in welcoming you to the National Workshop on Popularization of Remote Sensing based maps and geospatial information. Indian Society of Remote Sensing, having 5,000 members, has been in forefront in popularizing remote sensing in the country as well as in the Asia Pacific region. The Society celebrates 12th August, the birthday of Dr. Vikram Sarabhai, the father of the Indian Space Program, as the National Remote Sensing Day. The topic of today's workshop touches everyone and hence the country. Why map or geographic information is so important in the development of a nation? It is because the word map explains the relationship between different objects or the processes or phenomena or the functions. In other words, it explains the physical relationship between the features or objects, natural resources, infrastructure, climate, and people. Thus, the nation development or a growth depends on the information derived from the interrelationship between these aspects. India is growing rapidly and will continue to do so in coming years. The major challenge is to sustain the growth. We need to address the issues related to water resources, agriculture, energy, urban and rural development, transportation, health, education, environment, and many others. The transformation of India will depend on our understanding of the needs and the aspirations of the society, participation of citizens, academia, industry, accountability of governance system, and delivery of effective services. We will need robust information and decision support system for planning and implementation of various developmental programs. Remote sensing and GIS has been mainstay around which such information and decision support system have been built. Today, with matured remote sensing, global navigation and geographic information systems, and advances in computing and communication technologies, it is possible to build such decision support systems and provide location and web-based services. In India, during last 30 years or so, remote sensing has been used by many research organizations, national, state and local governments, and good knowledge base has been created. Private entrepreneurs have also shown many innovative applications and shown viability of commercial ventures. We have planned today's workshop to popularize remote sensing technology and applications and enhance use of remote sensing for improving quality of life of our citizens. There are many such examples. The information on weather touches everyone. The use of satellite data in weather forecasting models have tremendously improved the forecast of the weather. Our Prime Minister, during his program on Mann Ki Baat, encouraged all citizens to use this information for day-to-day activity. That shows the kind of improvement which has happened in the weather forecast by using the satellite-based information. The tsunami warning system, built around geospatial technology, is capable of providing information about travel time and run-up heights of the tsunami wave at 1800 locations along the Indian Ocean is another example. This system is completely automated and conveys an accurate tsunami information to all stakeholders within minutes. Similarly, for cyclones, the forecast of landfall point, wind velocity, and direction, as well as inundation, have been proved to be extremely valuable for saving lives. Satellite-based services provided to farmers and fishermen have dramatically changed their lives. The information on potential fishing zones and sea state conditions are provided daily to the fishermen for very efficient fishing. Today, most fishermen has been using this information very effectively. The weather service provided to farmers have proved to be very effective in increasing the productivity. According to National Council of Applied Economic Research, these two services have brought annual benefit of about 100,000 crores every year. These services are built around GIS and uses remote sensing, communication and information technology very effectively. This allows local, state and central governments as well as society to make informed decisions. We need to build such services for many vital sectors such as agriculture, health, education, rural and urban development, infrastructure, etc. It is envisioned that today's workshop will address various end-to-end application needs through development of such and decision support systems by innovative techniques. The Indian Society of Remote Sensing believes that remote sensing and AI should be a means for planning economic, environmental, as well as social programs. The current exercises, including today's workshop, certainly enrich the national capability of using space technology and GIS. We are of firm opinion that India is now ready and prepared for inclusive development, informed governance, and providing citizen-centric service. I urge all participants to this workshop to contribute towards the enhanced use of sensing information in the development of our country. Thank you very much.
On the occasion of the remote sensing day, let me greet all of you and remind you that remote sensing has come a long way in our country. With availability of various data on our satellite programs, the country is using remote sensing to a number of applications, starting from disaster management to prospective zone and identification of correlations and various program monitoring and planning tips. ISRO starts work on satellite technology back in 1975 with Aryabhatta as its first satellite, and first satellite developed in the country was the Bhaskara 1 and 2, starting with a resolution about 1 kilometer. From that time to till now, a very huge capacity, and we have more than about 18 satellites providing information, observation information from orbiting satellite to geosynchronous platform. They have capabilities, main resolution, and physical observations, and everything of the country sounds use geosynchronous platforms. And use all this, we have a number of platforms and that providing very useful data for a host of activities which help us in doing disaster management and disaster slow warning, for how the changes are taking place in land use, land cover, and then proactive fishing domain. And today, activities of geospatial nature with geotagging has taken a big way with MGNGA or the Mahatma Gandhi National Rural Employment Guarantee Scheme activities being under the geotagging. More than 1.5 crore assets have come into operation, and similarly, the postal department has brought in all its post offices onto the database, and the vision of being second to none in the case of technology for addressing the problem of our country. Indian Space Research Organization has provided a huge capability both in remote sensing, communication, and navigation. All of them lead to significant capability in making decision making in an informed way, and also in planning and monitoring of the activities. So, and this particular workshop and the activity planned by the Indian Society of Remote Sensing to familiarize with technologies where people is an extremely important and welcome, and let me congratulate the entire team for this work, and also we all a great opportunity in putting to use this excellent technology for various activities in the country. Thank you.
Though human beings think that they are the master of the nature, but they survive with the nature. And nature provides food security. Nature provides them water, and consequently, the nature provides social and health. When we say we do assess nature, we try to see that which state we benefit humans, and sense is to measure nature and measure the effect of nature on humans. Then we observe our space. The space in advance, we measure it on medical, can happen local, and we understand nature respects no border. And the natural effects in India is also natural effects. Also the band temple visit with the requirements of ocean atmosphere. I'll mention that photo we have to measure the image the area during the cropping process, and that or the we call it a crop phrenology. Similarly, any atmospheric activity coming like a storm, even the southern 40-degree wind speed, all that as and when the events occur. And another situation we can observe at different loops and specifically different angles and also different bands. Those operational Earth observations started in 1997 from the launch of IRS-1 day. And as we progressed over the years, our imaging capability increased both in terms of coverage as well as in terms of resolution. Today we have, in just the present day, we have a imaging capability the meter as well as measuring at a resolution of 1 kilometer from geo orbit. And as we look forward to the future, we ISRO very light will have a not only high resolution sensor, but will also have a multispectral and hyperspectral sensors in the Earth's atmosphere, Earth's oceans, and Earth's surface. Let us go to the first microbe instruments. Let me tell you that Earth can be observed in the normal light which our eyes see the nature. But beyond this optical spectrum in which our eyes see, there is a host of frequencies in which Earth can be observed in a much better way. I can give you an example, that when you take a photograph in this like our sees, we see this photograph as our eye sees. But imagine that you are taking an image with an X-ray, then you will be seen and your skull will be visible, your bones will be visible, but both are both give a different type of information in different ways. Exactly similarly, that the nature can be observed not only in optical frequencies, not only in infrared, it can also be like in a microwave bands. And those observations will actually give a set of what I see. We about microwave instrumentation, we had a very early beginning. India's first satellite Ankara 2 carried a Samir payload. It was an Earth observation at a 21 gigahertz and 31 gigahertz. Then it took a while to this technology to pick up in ISRO. We built an airborne in 1985 to 90, and we had a number of flights. We understood two things, that how X-band in X-band is different than optical. Then we also understood how to build a complex radar instrument for imaging purpose. And we implemented the airborne SAR technology. We built it in 1989 to 2002 time, and also at the same we have the celebrated which was known IRS P4, which later recrested as OceanSat 1. We have improved the imaging capability by radar and went in a much further. We had a multipolarization measurement, multi-resolution measurements, and very vast measurements. And first time we improved the resolution from in ASR case to less than 1 meter in the DMSR. The remote sensing really good and synthetic aperture radar in space in 2012. It was not only it provided a imaging capability of a many different resolutions, 1 meter to 50 meter, and a swath capability from 2 kilometer. And in this process, also we have in this satellite for the first time a new polarimetric concept was introduced called hyperpolarimetry. Also, first time we have introduced a polarimetric spotlight SAR capability, probably the first in the world, and that too with by from 10 by 10 kilometer to 10 by 100 kilometer. This is the longest spot imaging capability ever in space. We had a also very significant development of launch of Megatron. It is a collaboration between CNES France and India, and it had a radiometer as well as sounder. It is still operational, though the radiometer segment is presently. We had a Saral Altica. It is also developed in collaboration with the CNES France. They provided the payload, we provided the satellite and launch. And the best part of it, it is the first altimeter operating in Ka-band, that is around 36.5 gigahertz, in which that hitherto today the altimeter information is available with the best possible resolution. The most celebrated one was the SCATSAT-1. You see that a SCATSAT-1 was launched in 2017 as a replacement of a OceanSat-2 scatterometer, which became non-functional in 2014. And this has a capability of providing ocean wind information at a 6.5 kilometer resolution and land information at a 2.25 kilometer resolution. But the advantage is it will cover the whole globe in 2 days. Such a synoptic and temporal observation is not possible through any other sensor. India's Earth observation satellite program had a nascent beginning with the launch of Bhaskara 1 in 1979 out of a Soyuz from Soviet Union. And this was our first satellite. It was built indigenously. It had 2 sensors, one TV camera as well as one microwave radiometer. It was important that India's first satellite was dedicated for observation of nature. Subsequently, we launched Bhaskara 2, but a very first operational remote sensing was developed with the launch of IRS 1A and 1B 1989 and 1991. They were launched from Russian launcher, and subsequently our PSLV launcher started operating, and we had a series of launches from IRS-P to IRS-1C and 1D. In fact, IRS-1C at its lifetime was the best satellite available worldwide in terms of resolution, and its data was sold globally. And also this 1C and 1D had the first time had a stereoscopic observation capability, which was utilized very significantly for generating the first set of stereo images. And the IS-1C and 1D brought laurels to India. This is the first time it had a resolution of better than approximately 5-meter resolution, and it was respected all across the globe, and this data was globally used. And ISRO's credit is that the world's first high-resolution satellite was developed in India itself, and it provided a significant application in both optical band and the near infrared bands. The ocean applications got a fillip in the launch of IRS P4, which subsequently rechristened as a OceanSat 1. It had two payloads. One is the ocean color monitor, and the first time on 8 channels we could measure the phytoplankton over the ocean. In fact, the phytoplankton signatures and the sedimental signatures, they gave us an information of availability of the very food resource at the bottom of the pyramid. And one should know that whenever the phytoplanktons are there, the zooplankton should be nearby, and behind zooplanktons there will be fish. In fact, this sensor provided an operational support to fishermen to decide on the right location for fishing operation. It had that MSMR payload, as I explained beforehand. And OCM-1 provided that the first time an ocean information service, which is available through MOSDAQ satellite, and also the ocean information service aided by the OceanSat 1 spectrometer, MSMR satellite, and we have a host information from ocean wind to ocean current, as well as a phytoplanktons on ocean from a number of our satellites. While we are developing the imaging sensors, we realized that there is a need for dedicated sensors for assessing the vegetation resources all over the globe. And it is important that this sensor, multispectral should have a sufficiently high resolution to image the crop boundaries. Also, it will have that wider swath so that we can cover the earth in a shortest number of time. In fact, this has a AU satellite which has been, though the covering the whole globe within 5 days. In fact, this AU's payload has become a tool with our scientists who are working on the crop assessment, monitoring, and prediction. In ResourceSat 1, we have demonstrated a multi-resolution imaging from as high as a 5.6 meters resolution to 56 meters and intermediate resolution of 23 meters but correspondingly different swaths, and one can see that the sensors that imaging capacity from 56 meters to 5.6 meters. At the same time, we started to give a product using the resource set data as well as many more ground observation data. In fact, we first made a wide distribution of ground sensor to measure the agrometeorology, and we combined this with a resource set product, and today we have a whole lot of services which are available in Veda's site. They range from soil wetness index to all the way to the crop and vegetation index all over India, and their variation, but their temporal variation with season, with years. And our geo satellites, which are carrying insert 3D or insert 3D type of payloads, they provided information of cloud coverage of India, and they, together with this cloud information as well as the sun angle information which can be computed mathematically, we are providing a measurement of global horizontal irradiance, and this information is one of the major product which is needed for operation of solar power grids. And wind energy is also coming up, an important resource which has no pollution. But for this we need a wind estimation, especially that wind strength all across the land and as well as in the coastal region, so that we put wind turbines at the right places and we can maximize their energy potential by assessing and predicting that the wind variation over the day. For this purpose, we are providing a high resolution survey over all of India and its coastal regions in our Vedas portal. High resolution observation was one of the key requirements for resource monitoring and specifically for infrastructure monitoring. We realized the importance of high resolution imaging requirement from our experience with an IRS 1C. We could first time observe at a resolution of 5.8 to 5.6 meter all the urban mapping requirements, and also we had a first cut experience of cartography as well as surveillance. We have launched the Cartosat 1 and two sets to measure the stereoscopic information. In fact, the Cartosat 1 had a dedicated sensor to measure the stereographic information of the land, and this provided first time India's official and India's own digital elevation model, which is called the Cartosat model. In fact, this model is not just restricted to India, it has also coverage of a large part of a globe. Cartosat 2S series of satellites gave a really different fillip. We have now the imaging capability in pan mode of a 0.6 meter and in multispectral mode of the order of 1.6 meter. In fact, this imaging as is answers, it is being used for now many development specific infrastructure activity management. It is also being used even for assessing the success of MNREGA programs. When we see that a high resolution imaging, if we have to increase its potential, then we must be able to correct degradation because of suspended humidity or fog or even very thin clouds. We now have a technology with us to correct for atmospheric degradation to quite a good extent. With our software from the data itself, I can leave you with an examples of such correction effort. we can see that one more example of this atmospheric correction. ISRO is credited to introduce atmospheric sensors or weather sensors satellites from geo orbits. In fact, the first communication satellite INSAT 1A had a very high resolution radiometer, which was used with 3 kilometer resolution in the Earth. And but subsequently, when the communication satellites went on becoming more complex, we have separated the weather related pairs from communications of satellite. We have launched through PSL Kalpana 1, which had the VHR payload. But there is a basic imaging payload. Atmospheric or weather sensors were introduced 3D imaging payload. We call it a sounder. It is a 19-channel sounder, and the 6-channel imager was introduced in INSAT 3D. In fact, it was a revolutionary change. We not only got it weather information on Earth's surface, we also get the information on a stratified atmosphere at different heights. And it made a sea change in the many atmospheric predictions that includes the cloud motion vectors measurement. And inside it has a sibling in inside 3D R payload, which was launched as recently as last year, and it exactly similar suite of payloads as INSAT 3D. In fact, INSAT 3D or DR individually they operate with all the imaging in an hour, and by shifting the imaging between two channels, now we are providing a combined information product which is sampled at every 15 minutes interval. Very less number of weather and atmospheric products are now available on 3DR, and they are available in presently in Mosdaq site, and they constantly are available on high site. Measurements are wide. Examples are given for a desktop temperature or measurement of the precipitable water, which is a given estimation of impending rainfall over that not only India but one-third of the globe under its observation. In fact, the INSAT 3D we could predict the heavy rainfall during the it's product and one product which was on the Mosdaq site. Recently, with an INSAT 3D we have introduced the air quality monitoring or the suspended suspended aerosol or suspected particles in the atmosphere is now available operationally on the site as well as available in the building suitable or for one availability of we first we had been load the camera which was 5 kg or capacity of just as well we developed electro-optical sensor for the space observation. They can be also used for company is considered and those businesses will be corrected very correctly in a for us. And we've been trying development model of this and also multi-spec mode or this mode a lot of is in business has also been developed improve and operates Airbus and the DSR facility or radar from air platform. Presently, you can see that certain examples of Egypt we are able to resolve the inducing the covering of a cell radar or SR present. But all the on macro radar is created in development of RISAT-1, ISRO's first synthetic aperture radar satellite. It was a C-band SAR and it had a capability of imaging resolution from 10 kilometer by 100 kilometer spot. This was a massive SAR with a SAR payload with 6 by with a 3 foldable parts in the antenna, each of 2 by 2 meter and a total electronic component was staggering. It was almost more than around subsystems and all the computers, which were all of them have to work seamlessly to provide the imaging capability. It had almost all the imaging capability which is possible for airborne synthetic SARs. They had a strip map as well as a scanner as well as high resolution spotlight imaging capability. We could cover a swath of 225 kilometers at a resolution of 50 meters to all the way imaging by 100 kilometers with a better than 1 meter resolution. You can see that certain examples of high resolution imaging capability for the images taken over Bangalore. We have carried out a dedicated anti-eye study using RIS sensors solutions like MRS, CS, or FS1, both polarized and a certain set of examples we can see for monitoring of breaking of ice shelves in Antarctica as is presented here. There is another set of polarimetric images of Antarctica as obtained by RISAT-1 and these are all awaiting interpretation by scientists who will be visiting the Antarctica in this year. There are also further examples of high resolution imaging of place which was imaged for the first time in high resolution SAR mode of I1. SCATSAT, which was launched as a follow-on of OCM-1, has been providing the splendid images over ocean, which measures wind speed along with direction at a 6.5 kilometer resolution to even 50 kilometer resolution. But this is the first time that a SCATSAT-1 data was used innovatively over the land. And using the super resolution capability, the resolution was improved from to 2.2 km and of measuring the complete ocean or the land in 2 days flat. And so we have a possibility of measuring many land related phenomena at a 2 days interval. and such an example has been shown over here. In our quest for excellence in SAR program, we are developing the NISR, the NASA ISRO synthetic aperture radar. It will be an unique mission which will measure the Earth's surface at a both L and S band. The L band SAR has been made by Jet Propulsion Laboratory, Caltech, NASA. The S band component, which is more complicated, is being built by ISRO at Space Application Center. The airborne version of the same system is being operated operationally for many users all across India, and this system is providing very nice images as you see here. And ISRO has developed also a very miniature synthetic aperture radar. It is in X band, which will be mounted in UAV and be used for imaging the ground information. Presently, we have built a synthetic aperture of and is from we have developed a technology array of technologies which can image Earth. Also in ISRO, technology to see millions and billions of kilometers away as is seen in astrosatellite. But seeing below Earth is a still technology challenge. Till today, imaging even up to 10 kilometers below Earth is a formidable task. We have started new beginning image below Earth. This is done with the development of a ground penetration radar. We have used it for measuring ice structures in Antarctica because it is important that Antarctica give you different evolutionary phases of Earth's history at over billions years. And for us, we built the penetration radar which has been tested extensively. And in Antarctica, we give you an example of the results. You can clearly see, even a layman can understand different strata in the ice as well as crevices, say a void space in the ice which could be detected, because this was very important for movement over ice and glaciers. So ISRO is not only working environment imaging in space, we have also started working towards imaging below the Earth. And I hope together we will be able to measure and assess the nature in a much better way than what we understood so far. Thank you.
Yeah, the topic given to me is space technology and its applications for the society benefit. Initially, I would like to introduce to you about the National Remote Sensing Center and its regional centers which are there in the country. We have Bangalore and Bangalore and Nagpur for regions. And in Hyderabad, we have three facilities. One is Shadnagar with the satellite data acquisition, processing, archival, and dissemination mechanism. And then at Dimetla, recently we started an outreach facility. And we have two aircrafts equipped with large format digital camera and all laser terrain mapper. And this is at Begumpet Airport, we have a facility. And then we also have a facility for data reception at Antarctica. And it is also continuously stationed by the colleagues to ensure the polar orbiting satellites to receive data from there and transmit to Shadnagar. And we have a facility called IMGOS, which will ensure less than an hour information transmission to the users from the satellite data reception. While coming to the data acquisition, and also the processing, the IMGOS is an integrated facility for multi-mission mode, the data to be accessed, processed and archived, and the system is such, and with the amount of data which is available in petabytes can be retrieved in less than 5 minutes to make it available for the user community. While coming to the dissemination, as per the remote sensing data policy, certain pricing of the products are available. However, today more of the products are made available on a free download mode on Bhuvan, and also through projects which is taken up on a mutual benefit, they are also made available for the user community. And while looking at the data processing part, there are ample opportunities available. As you are aware, today we have a host of satellites. At Shadnagar, we receive around 23 satellites, of which 8 are foreign satellites, rest are Indian. And to process this data, both in optical and microwave, there is a good challenging opportunities available for academia to pitch in looking at the frequency domain data processing. And the data which is available today from both from optical and microwave data used for any applications. These applications have been defined initially through a program called National Natural Resources Management System, with various ministries giving their requirements on what type of applications they would like to do, and what are the gaps which is there in the regular data collection process, and how we can ensure through satellite based remote sensing or through aerial remote sensing. And today we also use field based sensors or IoTs, where we collect data for processing for given. So these applications are all tailor made in using both earth observation as well as from communication and the navigation set of sites. So the solution is provided through using the LED information plus field data, and also certain modeling which is taken up, and an end-to-end solution is given to the users. So every segment today has ample opportunities for academia to pitch in, take up projects of relevance to the national development. Some of the examples which I will go in when we are getting to the application. For example, in agriculture segment, we have crop inventory which is being done for major 8 crops, and today it is being done by the Mahanabali National Center for Forecast, located in Delhi. But there are new crops which we need to do, and there are 25 major crops which need to be assessed in terms of the inventory and also their yield. And in future, this is going to happen by at least in the next 5 years with the satellite data which is coming in. Should be able to do. And when coming to the crop pest and diseases, there are especially we have a sensor called shortwave infrared for satellite data, both in covering large area, coverage for AWIFs, which we have what we call as a 3-tier ranging from resource satellites. We have the shortwave infrared sensor, which is very useful for identifying pests and diseases on the crop. So there are studies have been done, but it can be a major program which we can put through, while integrating the AWS data which is available, which is a network which is available in the country. So this is an opportunity which the academy has to look in a big way, how the pest diseases and onset, how we can trigger and place it for the user community. And for the agriculture monitoring also is, one is on the crop insurance, which is done on Pradhan Mantri Fasal Bima Yojana. There are 9 areas in which these based inputs are very essential. One in terms of the rate fixing, that is the premium, and for the information on what type of crop which is sown and who are the premium which come, and subsequently in between there is a damaged crop, and also the crop assessments will be ample size to be picked, and should the turn time for percent of the systems in. But all this data needs to be processed, because there are only few agencies in the country which does such a very specialized analysis. So this is where we expect the opportunity for academia to take up projects of that nature, which is on a turnkey basis, for which we at Metla and all at the 5 regional centers, we are opening an opportunity for outreach related activity. And then coming to water and irrigation, in the and what is called experiment made. So the flow is well controlled with less of sediment discharge into them, and this is being done by watershed development programs. It's called Integrated Watershed Management Program by Government of India, the Ministry of Rural Development. And today we are the majority of the watersheds we are doing in terms of monitoring evaluation. That means the activity is being real, how it is being monitored, regularly evaluated. We have all with the planning inputs like the land degradation, groundwater potential, the land use land for last years, both in 5 years for 3 years, 3 periods, and also for every year on a certain information. This is very critical for understanding which is the priorities and what type of water and soil and land conservation techniques needs to be done. So, this is one activity which need to be done more aggressively, and also one is on the NREGA, National Rural Employment Guarantee Scheme, which also is converging into water conservation mission today, and that's possible only with the space technology to make the ministries understand the investments being made under different projects, how they can converge, use these derivatives which comes out of the space technology inputs, how they can be made for different applications. And we also have the water information today. Every 15 days, we are keeping the water body information onto the Bhuvan, which you might have seen on a video clipping on how it is being demonstrated to you, what its utilities are. These 15 days water bodies is helping in understanding the potential use of water and what are the constraints during drought and what are the alternative methods which can be followed. But also it is being looked as a future, a good project in terms of blue revolution. This is alternate third livelihood option for the rain-fed agriculture or in the rural segment is land fisheries. So it has been seen there is something like 3,500 tons of fish can be made possible from a district in Chhattisgarh, and such districts are around more than 160 districts are available in the country. But this need to be made in an organized sector, and space technology gives the very critical inputs. And also to place new ponds or farm ponds in the tribal areas. I have observed that the tribal ministry is keen to give as a third livelihood option for the tribal people, and we have a digital elevation model generated from the COTOSAT-1, which is one of the best elevation model to give the gradient and also the water storage which can be put through. So this is one segment which needs more population to the projects locally, either from the state government or from the federal government per se. And then the irrigation potential itself to look in the network of the canals and to what extent the canals have been fully made. This is being a technology done for more than 200 command areas. So the using the Bowen resources. And today it has been, technology has been transferred for the Ministry of Water Resources which they are on. But today the under the group of secretaries, it has become one of the element where we need to monitor in terms of actual potential versus the actual realization which is happening, and that is one major project which is going on. And the group of secretaries which discuss on the future outcomes of one of the projects which you can see is on soil health card. That is how the information will be available for the farmer, so the micronutrient deficits, and also for the industry to make fertilizer and to make the fertilizer blends for a given region, and need to be monitored regularly. So the usage, when impact is made, how to ensure the subsidies and also the usage are normalized from the field end. But this needs more field investigations and also the research components which are available, which needs to be studied further. And one of the other is on solid waste disposal. You are aware many of towns have been identified and cities are coming up, but the solid waste disposal is one major element. You can see on Bowen, you have information homology, the groundwater potential, land cover, and gradients which you come from the digital Carto DEM. These are all the inputs which needs to put on solid waste disposal suitable sites. And so have been now academia can take up directly with the town planning departments or the required government agents how you can put through. This is from the rural segment. But and also we have one project where we have extensively database on space-based information support for decentralized planning. That means up to panchayat level or village level planning can be attempted. So based on roads, the network, the bridge, bodies have been mapped and all. There's a one has been given issue what is available, gap areas, and for filling the gaps, how the planning can be done on both panchayats. So there's an SOP. Today, more academic issues are project EPs and is available at many places. You also will recall on Bowen we are having 1 meter and also 2.5 meters. Data will be periodically every year. It is going to be new data is going to come, and also the AWIPS data 4 seasons information will be are being placed. So there is an ample opportunity for academia to look in what is the best way to process. Urban applications, you are aware, under National Urban Information System, around 140 towns, the mapping at 1:10,000 scale has been completed, and that is being used for the planning purposes. But in the new Amrut program, around 500 cities, where on a scale of 1:4,000, the base maps or the base information will be provided on Bhuvan, and the town planning departments will be doing and plan process online on the Bhuvan resources itself. That means what is the today's existing plan, and what is the demand which is coming the next 5 to 10 years, and how well we can plan for the incoming population and their requirements. And the urban plan and the master plan will be published on Bhuvan itself, where you have a discussion forum where people can interact and look into the changes what's happening. You also should understand the potential of the stereo data which is available not only on the Cartosat 1 series, but also on the multi-viewing capabilities what Cartosat 2 series facilitates us. And you are aware, today we have the Cartosat 2 series with 65 centimeters resolution. That means we are capable of doing maps at 1:3,000 scale and 1:4,000 scale. And such information has the details of even the rural villages. When it is shown to the parliamentarians, they feel as if it is taken from aerial cameras. Such is the capability which has been done with indigenous optics and the payloads from our Indian scientists. And such data is quite valuable for any of the urban projects and also the infrastructure. Infrastructure in terms of the roads, the new road networks which made, also the railway alignments, and also the buildings which is going to come. You also aware, or you aware, things like NBCC, wherever the new construction sites which they are going to make, how they will align using the state-of-art data which is available. And also for things like energy segment, the micro-hydel stations, more than 100 micro-hydel stations are using the Cartosat digital elevation model. And also the material available for construction of roads in the northeastern region, the major application being done by my colleagues for the model has become very important input for the forecasting models. And a flood vulnerability index map has been published on Bhuvan using 100 years of climate data, which is very useful for the academia to look in the peak runoff rates and the runoff volume, which can be created for many of the bridges, the life of the bridges, and what is their susceptibility can be very well done. And this is all published on Bhuvan, where we can put in. And there's one simple example I would like to bring. When a group of secretaries has come on second green revolution in eastern India, and they want to identify the Kharif fallow, rice fallows. It was only a time of 2 days. Since the data is available, it's only to reprocess the data of which is available on Bhuvan has been processed and then could be made available for the respective governments as well as the 6 states which we can do. One point I'm trying to draw is all this information today is available on public domain, and that too from ISRO websites, both at MOSDAC and also from India WARIS, which has been developed for Water Resource Ministry, or from Bhuvan, and also we have a databases on NICES, and also we have on disaster management support program for 6 major disasters in terms of the flood or in fire or in landslides, etc. are also being placed on Bhuvan periodically and regularly. And one more important information is on the heat wave. Predictions also are being provided. And last year, the state government of Telangana has hosted this on their local communication network to reach all the villages and also all the schools. And this time the loss of life due to heat wave in this particular region has reduced. One is the information dissemination, and to the locations where it is needed. That is the most important part we should look in. And you all aware during the floods what we had in Kedarnath and Badrinath, we lost a lot of life and also infrastructure. To assess the infrastructure loss, it has been suggested that why we should not take up the space-based remote sensing in such an activity. But here we took up a different way of studying in crowdsourcing. That means locally students who are accustomed with that kind of a terrain, which is a very tough terrain and a harsh terrain to move in. And we made a mobile apps which is accessible onto the Bhuvan platform. And we have seen before the next winter season starts, there are more than 1,000 points. Today more than I think around 20,000 points are available where we could assess what is the real loss or the failure of bridges or the buildings in terms of the cracks. So this now has gone a long way. All the projects of Government of India where the investments are being made are being used by space technology. One from observation from the space, from satellites, or second is from the field information in terms of geotagging the assets. And once the assets are geotagged, depending upon the requirement of making an ease of doing business, which has happened for the Ministry of Culture, to look in how the existing monuments are there, and within that reach, within 72 hours, an approval cycle has been made by the government and has been published. And this is where the space technology is trying to help in doing ease of doing business. So all the applications data today which I am speaking on the societal benefit are available on public website. So the opportunity future, what is it on data analytics? And this data analytics is going to be a big game changer. And the next century is on data analytics, and I request all the academia to take up more proactive role in interacting with any of our ISRO centers located across the country and have a dialogue of your interest and also the interest which is from the local developmental agencies which is needed for these specific purposes. In future, for the next few years, the ISRO's role is on space applications, which looks at in socio-economic security. The socio-economic security deals with food security, energy security, water security, shelter, the infrastructure, and also on information. And this is where we are trying to continuously provide the data processed and as a value added services which we will put in. We have one point is on the science related data, we have a NICES website. I request you to kindly look into those parameters. 13 out of the 26 ECVs information is being processed and regularly placed. So this will be a valuable input for the academia. While coming to the sustainable development, which is another pillar on the applications, we are looking at sustainable development in terms of agriculture, urbanization, or impacts of climate change, biosphere, geosphere program. So these all varied information we need to be assessed by academia morely. Today there is a mechanism of planning for urban, planning for forestry in terms of forest management plan, which is supposed to be a sustainable plan. But an audit or an assessment need to be done by academia, which active role has to be taken up, and the data will be made available for such kind of a processing put through. The third is on disaster risk reduction, where today we are looking at the response and recovery, but more importantly the planning part of it to ensure there is no loss of life, or also looking into the flood hazard zonations or any hazard zonation, multi-hazard zonations which need to be made where we can prepare the people without any loss of life in those particular regions. And overall putting all these three comes under the governance, and that governance in terms of the planning, monitoring and evaluation, and also decision support system which is needed for that particular aspect is overall applications goal. But for applications we need satellites, and for that satellite we have the space infrastructure which is in place, and for the space infrastructure to be placed, low cost access to space to the launch vehicle, and the capacity building for such infrastructure is one of the outreach facility which we have brought in recently, which will go a long way. So I request most of the academia who are hearing me here is a sincere appeal from Director NRSC to contact the colleagues, ask for bigger projects, but of relevance to the people, and that is where the societal benefits can be made for a larger segment to come forward. Thank you.
Extremely happy to be associated with this program today, where we are talking about popularizing remote sensing and geospatial databases for mapping and developmental activities. My focus of today's presentation will be on Bhuvan based geoportal activities that has been started by ISRO some time back. I would like to give you an update of the various actions that has been taken by us, which enables the geospatial data to be used extensively in the country, both at the central as well as the state level. As we all know, Bhuvan was brought into the public domain in 2009, around August 2009, and this occasion proved to be a very interesting occasion because we did a lot of work in just about 6 to 8 months to realize Bhuvan geoportal. The advantages and significance of this Bhuvan portal was that it consisted of completely Indian images and Indian maps put out on our own geoportal that has been operationalized using the open source platform. When we realized it, it was the best resolution what we could put that time immediately for the entire country was 5.8 meter resolution. But subsequently, a lot of activities have taken place on Bhuvan platform, wherein it has enabled much higher resolution satellite data as well as large scale maps that can be used by the user community. Today we are talking about 2.5 meter resolution as well as 1 meter resolution satellite data that could be used by the user community. And we also have plans to have regular updates of both these resolutions of data so that the users both at rural and urban can utilize this data for varieties of activities. We predominantly use for the Cartosat series of satellite data for very high resolution imaging, including the ResourceSat data for multi-temporal and multi-spectral coverages, which helps images to be rendered in color at the same time making the thematic maps easily analyzable and understandable. Bhuvan has a very interesting combination of tools and technologies, which possibly I will be highlighting to you shortly. Bhuvan basically looks at the two-dimensional and three-dimensional images that can be rendered at high resolution. In addition to that, it has vast number of mobile applications that can be used, and it works on any type of a platform. User need not be really worried about the different types of platform he has. So it could work on a Linux machine or a Mac or even on a Windows machine. Basically, the Windows based platform was the initial release, and subsequently we released it out on to the various other platforms also. If you see the journey of Bhuvan has basically got released in 2009 as a simple infrastructure. We just started off with 8 to 10 servers. Then slowly we improved upon the infrastructure because we started realizing the requirements of the user community and how we can leverage the infrastructure as well as the networks so that we can reach out to a large number of people. Of course, initially the first day of release we had more than 5 crore people trying to log into Bhuvan, and we did have trouble in meeting the responsibilities or requirements of all the people. But we could realize quickly, and then we made a lot of tweaking on the software so that it could be reached out to a large number of people. So the phase 1 and phase 2 from 2009 down to 2013-14 saw a lot of changes taking place with respect to the server farm build-up, the infrastructure build-up, the huge amount of hard disk space build-up. In addition to that, varieties of other tools and technologies that we could make available so that quickly we were able to meet large number of users. At the same time, see the requirements in the future and look at the visioning of Bhuvan so that we could meet more challenges in the future. But the most interesting thing that happened was subsequently, that was in 2014-15 onwards, wherein we were able to bring in large number of servers. We added about 34 servers into the system, and that was able to give a lot of information for people at a faster rate. And we slowly started building the systems in a distributed platform so that we can reach out to the people through the regional servers. So we tried to build some regional services through the regional remote sensing service centers of NRSC, wherein we were able to add additional servers in that. At the same time, during this particular time frame in 2013 and 14, we had large number of software releases including APIs. We had 31 releases in 2013 and about 26 plus releases in 2014. Basically, these are special services for the user community so that the users can utilize various technologies. So slowly the platform turned into a national geospatial governance platform in addition to the developmental aspects, and also major flagship programs of the Government of India started trickling into this particular system, in addition to enthusing the state governments also to start looking at Bhuvan as a one-stop shop solution for varieties of their requirements in the states. So if you look at the journey, we started with a small number of servers. Today we are talking about 70 plus servers. It's a bigger server platform. It has distributed computing environment. That means a central server platform is there at NRSC. At the same time, you have regional platforms, you have state level platforms, and also a few central government platforms are also hosting Bhuvan at their respective installations. And we are around the corner, ready for releasing another 100 servers as part of a major update of the hardware. That means we are going to be reaching out to larger number of people, larger number of users in a very short time. So this particular build-up has helped us to leverage both the computational platform as well as the network-based platform to see that this particular engine can reach out to large number of people. Of course, there are large number of challenges when you go on adding the hardware and the networks. We also need to have large number of applications developed and reach out to the user platforms. So if you look at the Bhuvan geospatial platform, it has different types of facilities. In fact, the entire facility that is available on Bhuvan is showcased in the very first mashup itself when one enters the Bhuvan. It is particularly started off as a visualization platform, but down the line we have moved into the mobile platform. We have more than 60 to 70 mobile applications that are operational on Bhuvan. In addition to that, large number of maps and map analytics are possible, and there are state-based platforms wherein respective state governments will be able to use this particular data for state-specific purposes. And of course, the state governments can build over it by putting their own data and inserting onto the system. The very interesting thing about Bhuvan, in addition to all these, is that it has got a one-stop shop for all the kind of disasters that the country faces. So it's a very good platform for disaster management support. If you look at the technicalities of Bhuvan, Bhuvan services particularly, not only that it can be used as a non-plugin service, you can use as a plugin service also. In the sense, we have the web map services, we call it as WMS services, which is quite popular in the world. Everybody uses it, but we have used it very significantly both in terms of the images rendering as well as the map rendering. And both these services from the map and the images goes through the WMS to large number of people. In addition to that, we have terrain services also put out. So all types of services that ISRO can give it to the people through the applications are made available from the WMS services, and it is particularly user-centric. When we really look at the application development, there are varieties of scenarios by which the users can utilize this particular data. We have the map server, that's the basic engine which actually serves the maps and the images to the people. We have tile caches, that is all these images and maps are actually put out, processed rather, not put out, in terms of tile caches, and these are positioned as part of geo servers and geo web cache. Once you have this particular data available, it is possible for us to have a pyramidal structure of this particular data stored in the database, and once this particular data is available in the pyramidal structure through the network, it is possible for us to meet out large number of user requirements simultaneously. That means this particular cache which is available will be able to serve large number of users simultaneously over the network, so that user gets the rendering as though the whole thing is happening on his own system. In addition to these maps and images, we have also added city survey maps, the cadastral databases, and even the ward boundaries and things like that, so that locale specific services can be utilized by the user. We also are looking towards the development of user-centric applications. User-centric applications looks very specifically with respect to the user, the way he would like to develop his own applications on a server given to him. For example, I mentioned about the regional services, the state-based services. State-specific services have the servers located in the respective states. They can have their own user services positioned by developing their own apps. They can also position their data and start pushing their data through the same service platform for the user community. So we have central services coming out from the WMS and WMTS. At the same time, the data-centric services coming out from the user who host these kind of services from the respective areas. I was talking about the mashup which has been created, which basically serves as a versatile geospatial dashboard. If you look at this dashboard, broadly it gives you the visualization services which is on the top. We have G-governance services which are in the middle, which is basically when you go into the system it will be scanning through. You can choose any one of these services. We have specific application sectors where people will be interested in. They can enter into any one of these application sector and then look at what one can do with that. At the same time, you have the special applications that are built which could be used by the user community in different ways. In addition to these mashup, on the right hand side of the portal you will also see the state portals where any particular state can be picked up and get into the details of the various states. Some examples of how the rendering of this particular data can be shown to you. We have very high resolution data which is possible today because of the availability of Cartosat 2 series of satellites, which enables us to put 1 meter resolution of data very easily for large number of areas, which can be used very smoothly and very effectively for various user community based requirements. In addition to that, large scale mapping possibilities are also there, wherein it allows programs like Amrit and smart cities could use this particular data. The example which I am showing here is a very high resolution map of thick urban population, which can be very nicely mapped, and you can bring out these kind of maps which could be usable by the user community for specific activities of urban development, urban planning, and even coming out with the master plans. Not only this, the Bhuvan also allows you to bring in the real life image textures on the footprint of the satellite data. That means you have the high resolution footprint and you can make image textures by taking the photographs on the ground. Especially it will enthuse the younger generation when they would like to take ground pictures of some typical monuments, for example, and they would like to position that on the top of the footprint of the image, so that it gives you a real-time rendering, real life image rendering on the top of a geospatial platform. So Bhuvan supports these kind of things in the 3D platform. What I am showing you here in this particular slide is the Mount Everest. I don't know how many of you have really gone to Mount Everest, but you can do a virtual reality of Mount Everest online when you look at the imaging capability of Bhuvan. What I am right now showing is the peak of the Mount Everest, slightly improved part of the image, but one can go to the three-dimensional platform where you can start looking at the visualization of the Himalayas itself. This is a typical example of rendering how you can do. You can see the top of the Everest very clearly shown to you, and the various snow and glacier exercises that can be done by a user who would like to understand the three-dimensional possibilities of this particular terrain. We are trying to move into more amount of analytics today on the Bhuvan. Technically speaking, we have been working on the parametric classifiers earlier days. We are trying to build newer techniques and newer mechanisms by which younger community can participate with us in developing tools for machine learning and deep learning techniques. We are all aware of the artificial neural networks that has been used pretty extensively for mapping. Particularly the self-learning and backpropagation techniques have been extensively used, but I would like to encourage the younger generation to work with us on newer techniques, particularly with respect to the deep learning techniques, which is becoming quite popular for varieties of classification of images and even intelligent image classification and things like that. In addition to that, ISRO also looks at evolutionary algorithms to be used, like genetic algorithms for classifiers, and also the nature inspired optimization algorithms, which are very important for rendering and even classifying or even processing some of the large amount of data that we are getting into the system. Today, Bhuvan handles terabytes of data on a daily basis. We need to have innovative methods by which we can handle large amount of data. Some of the typical examples of large scale maps are shown here, wherein one can use it for tourism purposes, or it is possible for you to use it for municipal GIS and things like that, including positioning the Bhuvan for even school. NCERT syllabus is put onto this particular system. Entire schooling community in the country can use school Bhuvan techniques very clearly. ISRO is moving into a newer area for location based services today. We have the constellation of Navik available with us, and we also have the GPS aided geo augmented navigation system. We call it as Gagan, which allows you to go down to something like less than 2-meter resolution on the ground when you are using this particular tool. These two technologies are allowing India to use indigenous techniques for location based services. There are many examples which are coming forward. For example, we have many applications which are available on mobile, which talk to the Navik through a simple first generation device which talks to the mobile device through the Bluetooth. It is possible for you to use the indigenous GPS system, and a large number of applications are already built on this. I thought I'll specifically highlight some of the applications on disaster management, particularly on the flood, forest fire, cyclone, landslides and earthquake, because these are the applications which are important to be highlighted. The other applications are already highlighted by some of my colleagues who have talked about Bhuvan and also demonstrated Bhuvan. If you look at the kind of disasters the country faced in 2013 and 14, I think some of the rare events happened in the country which created a lot of problems for us to have better preparedness. That is the time onwards ISRO started moving into near real time imaging, near real time positioning of our Bhuvan based disaster management support system. If you look at the example of Uttarakhand, we had a major problem in Kedarnath, which made us learn a lot of new methods by which we can try to give near real time pictures of the kind of things happening on the ground. This particular image highlights to you the actual Chorabari Tal disaster, wherein the entire water, due to very heavy incessant rain, that created problem on Kedarnath. This is a three-dimensional output which has been generated from the Cartosat series, Cartosat stereo data, which allows you to visualize and understand the complications involved in this particular area, when we witnessed more than 5,000 landslides in a very short time, and we were able to quickly analyze the data with multi-time data, and also we were able to position a GIS data on the amount of impact that created on the dwellers of this area. In addition to that, we have quickly brought in various software tools for looking at such kind of problems through geotagging on the ground that can be used for field data collection. A lot of users have started using it as part of the crowdsourcing, where mobile apps are being used on the ground for giving wide varieties of data. Uttarakhand disaster itself was very closely seen by about 100 students in the field, where they were able to use our mobile tools and provide large amount of data in a short time that could be positioned on the portal, which were of great use for the local authorities. Manu was the program, basically mapping the neighborhood in Uttarakhand. In addition to that, we have an active system which gives SMS alerts on near real time mode for locating the forest fires that could be countered on the ground. Here is a mechanism by which the daily active fire alerts in the fire season is activated using this particular system. This is an example of how we did it for Uttarakhand, which was one of the recent forest fires which we faced. And during this entire season, all the forest department get direct information from our SMSs, which are linked to 4-time alerts that we get from the space-based systems. On the flood front and cyclone, this is an example of Filin, wherein we are able to exactly track the path of the cyclone right from the prediction, early prediction onwards. You will be able to exactly get the details of when it is going to strike and where is going to be the landfall, so that the ground system particularly the collectors and the authorities at the local level will be able to plan well in advance. Both the Hudud and Pylon were very actively ISRO actively participated in these things and provided excellent pictures on a regular basis, and today in fact India is in a very good position where INSAT 3D and 3DR gives you every 15-minute location information, particularly on these conditions. In addition to that, the regular weather monitoring can be done using our systems. You can see the example here wherein post disaster also we continue to provide the pictures where it gives you the exact inundation where it has happened, and you can zoom into an area where even up to the village level you can get the information, which is highly useful for the local authorities. This is another example where again the geotagging techniques have been used under the disaster conditions to see where exactly the trouble has been placed on the ground, and this kind of real-time pictures from the field also helps the ground authorities in understanding where exactly what has happened. This is an example of Hudhud where it gives you information about the kind of disaster that has struck on the ground. At the same time, the classification of information with respect to the mobile data that provides us exact information about the kind of problems that has been faced. Moving to the other areas where we saw major disasters, particularly in the case of Srinagar, the Jammu Kashmir in 2014 experienced massive floods in this area, which again enabled us to quickly position our systems, and we were able to move in a lot of data for the local authorities to use this particular data. At another new area in the higher reaches of Himalayas, which we are using quite consistently, is on the landslides. The Puktal landslide was very accurately analyzed by us, and quantitative information was provided not only with respect to the debris that was formed, also with respect to the exact calculations of the amount of debris which is there and the mechanism by which one can clear it so that you can release the water systematically. An artificial lake kind of a situation was formed as part of the transboundary landslide impact also, wherein Nepal had this problem of landslide which created problem, and we could work with Nepal very closely to see that we could avert a major disaster that could have caused, just like the Kosi river disaster which had been caused earlier. This was again on Sun Kosi, we were able to solve it. So space is helping in a big way through the Bhuvan geoportal, so that we are able to avert many different types of disasters which occurs anytime in the entire season. Particularly the rainy season causes more problems as compared to the others, especially in the cyclone conditions. The conditions are much more severe, but nevertheless the disaster management support system of ISRO through the Bhuvan is always available for the entire country to utilize it in a meaningful way. Before I close, I would like to say a few things wherein we would like to also talk about what we would like to do for Bhuvan in the future. Bhuvan is moving into the big data analytics because Bhuvan gets diversified data. It's not just the image data, we get the map data, we get the field data, we get the data from mobile platforms, we get the data from even UAVs. So when you have versatile platforms by which you are able to assimilate this kind of data and use it for various analytical solution so that the users can quickly get the results out of the multiple data sets what comes in. So Bhuvan looks at the big data analytics in the future. Yet another important area Bhuvan obviously would like to look at is the intelligent data processing, and we would like to have a large number of younger generation working with us to see that they become shoulder to shoulder with us and solve some of these intelligent data processing problem. As I mentioned already, we are into the machine learning and deep learning techniques, and we would like to make them online available, particularly which we don't have today. We would like to process such kind of data online so that large number of users in the country get the advantage of this kind of data availability. The universe is going towards 40 plus zettabytes of global data, out of which 2.5 plus zettabytes of data will be poured in by India itself by 2020. If you look at the Facebook today, we talk about more than 700,000 updates per minute. And if you talk about the Twitter, which generates more than 12 terabytes of data per day, when we are looking at such kind of data, Bhuvan, when we are talking about terabytes of data being handled on a daily basis, is not a small thing. It is going to be a big thing. So we need to look at a bigger solution provision possibility from the user community. we move towards that, and we certainly look forward to large number of users participating in making Bhuvan much more versatile, more user friendly, and at the same time reaching out to all the people in the country and meeting the requirements of the country through the governments both at the central and at the state. Thank you very much.
Good afternoon, everyone. First of all, my warm greetings to all of you on the eve of the Remote Sensing Day. In this presentation, I am going to brief you about the capacity building and outreach program of ISRO, Department of Space, with particular reference to geospatial technology and applications. Capacity building is an integral part of Indian space program. ISRO has taken several initiatives towards building human and institutional capacity to ensure meaningful utilization of geospatial technology. A few important ones are shown here in the slide. ISRO, through its different centers, is engaged in capacity building of individuals and institutions through training, education and research programs, and through handholding with user departments. It has strong and unique framework under National Natural Resources Management System called as NNRMS, which supports conducting the training programs for academia and stakeholder departments. A large number of students, researchers and academic community get benefited every year through training programs conducted by ISRO centers and by providing research guidance. ISRO conducts training and educational programs for international community through a United Nations center called Center for Space Science and Technology in Asia and the Pacific. In short, it is called as CESTEP or STEEP, which it supports, and also through the ITEC program of the Ministry of External Affairs of the Government of India. It also uses different mechanisms to reach out to the people to generate awareness and inculcate interest for space research, particularly among the younger generation. ISRO also has a vibrant teleeducation program for delivering educational services, particularly in remote and rural areas of the country. Through this program, about 60,000 schools, colleges across the country have been connected, benefiting around 15 million students. ISRO also provides financial support to academia for research and development activities through its RESPOND program. The main centers of ISRO, Department of Space, which contribute towards capacity building in the area of geospatial technology and applications are Indian Institute of Remote Sensing, Dehradun, Indian Institute of Space Science and Technology, Thiruvananthapuram, National Remote Sensing Center, Hyderabad, Northeastern Space Application Center, Shillong, and Space Application Center, Ahmedabad. Now let us see the programs conducted by these centers. Let us discuss about the training and education programs offered by IIRS. You may be aware that IIRS is a premier institute for capacity building and research in the field of geospatial technology and applications. The training and education programs offered by IIRS are designed to meet the requirements of various user segments such as working professionals at middle and supervisory levels, fresh graduates, researchers, academia, and decision makers. It has both the short duration certificate courses of 1 week to 8 weeks duration and long duration courses like postgraduate diploma, MTech, and MSc courses, which are offered in different specializations. Apart from the regular courses, it also organizes special and customized courses based on user demand. IRS has started its outreach program in 2007 to strengthen the academia and user segment using online learning platforms. Under the outreach program, the courses are offered in two modes, live and interactive mode and e-learning mode. We shall discuss a little bit more on this after a few moments. Further, IRS faculty also guides a large number of external undergraduate, postgraduate and PhD students for their projects and dissertations. As regard to the outreach program of IIRS, a countrywide network of institutions has been set up from where a large number of students and professionals participate in our live and interactive courses on basic, advanced and theme-oriented topics of geospatial technology and applications. The courses are free and open to academia and research and government institutions and organizations. Currently, over 650 institutions are networked with IRS under this program, and about 48,000 students and professionals have been benefited so far. You may note that videos of all the contents covered by the faculty under this program are available in EduSat 2004 channel of YouTube. You can see the URL on the screen. IRS has also developed e-learning courses which are self-paced and based on the concept of learning anytime, anywhere. One can join these courses as either 4 months comprehensive certificate course on remote sensing and geoinformation science, or 1 month certificate courses on remote sensing, GIS, digital image processing and photogrammetry. Courses are available in Hindi as well as in English language. It can be accessed through IRIS website, and also the registration is free and open to all for the learners. Now let us see the training programs offered by National Remote Sensing Center NRSC Hyderabad. This center, that is NRSC, is responsible for remote sensing satellite data acquisition and processing, data dissemination, aerial remote sensing, and for executing remote sensing application projects in collaboration with the users. NRSC is engaged in capacity building of user community in the area of geospatial technology and its applications, remote sensing ground systems and navigation systems. It organizes regular, spatial and customized courses every year to impart training to people working in the domain of geospatial applications. Training programs on Bhuvan are organized at frequent intervals to increase awareness among the users towards effective utilization of Bhuvan portal services. Opportunity to postgraduate students is also available for carrying out their dissertation under the guidance of NRSC scientists and engineers. Now, let's see the courses or the programs offered by Space Application Center, that is SAC, Ahmedabad. SAC is one of the major centers of ISRO, focusing on the design and development of spaceborne and airborne instruments and payloads and their applications. This center supports capacity building of students and researchers in different areas of remote sensing and their applications under its 3 major programs. The first program is called as SMART, which is an acronym for Satellite Meteorology and Oceanography Research and Training. This program, SMART, provides training and research support in the field of meteorology and oceanography using satellite data archived at Meteorological and Oceanographic Satellite Data Archival Center, in short it is called as MOSTAC, and also using other related data sets. Another program is called as TREES, which is an acronym for Training and Research in Earth Ecosystem. The TREES program provides training and research support in the field of Earth ecosystem processes using visualization of Earth observation data and archival system, that is VEDAS, and also using other related data sets. The third program is the SAC Academia Associate Program, also called as SAC OP. This initiative provides opportunity to undergraduate, postgraduate and PhD students to work with scientists and engineers of SAC for their internship dissertations in various domains. The Indian Institute of Space Science and Technology, IST Thiruvananthapuram, is the first of its kind institute in the country to offer high quality education programs at the undergraduate, graduate, doctoral and postdoctoral levels in the area of space science, space technology and space applications. The institute focuses on multidisciplinary and collaborative research to generate excellent technologies responding to the need of local, national, and global interest. It offers BTech courses in avionics, aerospace engineering, and physical sciences. It also offers MTech in different specializations and PhD and postdoctoral research in advanced areas of space science, space technology, and space applications. Now let us see the education and training programs. At the Center for Space Science and Technology Education in Asia and the Pacific, called as STEEP, this center was established at the behest of United Nations General Assembly in 1995 by United Nations Office of the Outer Space Affairs, UN-USA. As mentioned earlier, this is the first regional center for space science and technology education in the world and has its headquarters in Dehradun within the IRIS campus. Different ISRO Department of Space centers organize and conduct the academic activities of this center. SESTEP organizes postgraduate courses, that is PG diploma cum MTech program, and short courses of 2 to 4 weeks duration in different areas of space science and technology for the benefit of the participants from Asia Pacific countries, including India. The disciplines in which postgraduate courses are organized by SESTEP include remote sensing and GIS, which is conducted by Indian Institute of Remote Sensing, IIRS, Dehradun. Another course on satellite communication, it is conducted by SAC Ahmedabad. Global Navigation Satellite Systems, again by SAC Ahmedabad. Satellite Meteorology and Global Climate by SAC Ahmedabad. And finally, the Space and Atmospheric Sciences course by Physical Research Laboratory, PRL, Ahmedabad. Short courses on different topics, including small satellite missions, are also organized every year at different centers of ISRO Department of Space. ISRO has also designed and developed education portals for students and professionals at different levels. I would like to draw your attention to the 3 portals which are shown on the slide. ISRO's education portal, shiksha.isro.gov.in, provides videos and articles on space science for school and college students. E-learning portal of IIRS, as mentioned earlier, provides contents for online learning in geospatial technology and its applications. School Bhuvan portal has been developed recently for school students for practical and interactive exercises on visualization and creation of maps in a GIS environment. Apart from ISRO Department of Space, there are many other knowledge institutions in the country which are engaged in capacity building in the area of geospatial technology and applications. These include state remote sensing application centers. Few of them are also offering postgraduate courses in remote sensing and geoinformatics. There are few training institutes of central government organizations which also have the trained faculty and infrastructure to conduct the training programs in this particular field. Nowadays, over 150 academic institutions located in different parts of the country also conduct courses in geospatial technology and its applications at different levels, be it undergraduate level, postgraduate level, and also at the PhD level. With this, I close my presentation. Thank you all for patient hearing.
I am going to speak about high resolution data inputs and geospatial technology in planning at national and at local levels. As you all are aware, India is the largest democracy in the world with 1.21 billion population and has tradition of democratic institutions at grassroots level from ancient times. Soon after independence, India has adopted economic planning in the form of 5-year plans with initiation of first 5-year plan in 1951. Now, these plans, the policies and programs are formulated centrally from top-down approach with plans implemented at lower levels like state, district, block and panchayats, etc. Though it was a successful process in terms of development, however, such central plannings could not fulfill many local needs. They could not use local resources and many local environmental concerns were also neglected in the formulation and implementation of the plans. So, the Government of India through various committees consistently pursued towards decentralization of planning process in the country, and 73rd and 74th Constitutional Amendments Act in 1993 paved way for devolution of powers to Panchayat Raj institutions at district, block and gram panchayats. So, today development plan is done for the entire country spread across 29 states and 7 union territories with central, state and local governments. The local governments follow a multi-tier system covering gram panchayats, block panchayats and district panchayats. So, the workflow in planning is well organized with bottom-up approach, unlike in the 5-year plans where it was from top to bottom. So, gram panchayats basically prepare participatory plans and send them to intermediate panchayats at block level. Now, these intermediate panchayats further compile the information sent by the gram panchayats in the block development plan along with their own information and prepare a block plan which is sent to Jilla Parishads at district level. Similarly, Jilla Parishads compile all the information coming from block development plans and add their own information and send it to district planning committees. Now, there are urban local bodies again in the panchayats, so they also transmit plans to district planning committees. Now, district planning committee compiles all this information coming from Jilla Parishats and urban local bodies to form draft development plans and forward these to state for final approval, right. So, this is one part, and the second is there are a lot of motivational factors today for taking up planning exercise, where there is a tremendous scope for spatial inputs in planning process to complement the conventional methods of planning to bring in new perspectives, improve the quality of planning process and also add dynamic inputs on resources into the planning just before taking the planning exercise. These new initiatives of government like Digital India, Make in India and lot of initiatives from the state governments and other institutions are also being a motivation factors for spatial based planning exercise at grassroots level. And looking at satellite technology with a host of earth observation, communication and navigation satellites plays a key role in preparing developmental plans. ISRO, Department of Space, has proactively conceived and proposed spatial information for decentralized planning at the instance of erstwhile Planning Commission as an important program of spatial inputs in planning process. Now, this is shortly called as SysDip, which is taken up at national level as a mission by NRSA, which is the nodal agency in implementing this along with different state centers and different stakeholders at states and district level organizations for the last couple of years. With the initiative of Government of India on September 17, 2016, where scientists, policymakers and decision makers met together, exchanged the knowledge towards effective utilization of space technology in increasing the operational efficiency and identifying new areas of research for finding solutions. So, ISRO is today executing more than 160 such projects from various departments in different ministries using geospatial technology and high resolution data. So, space based information support for decentralized planning is one such project which is taken up by NRSA, and the core objectives of this project is to generate and produce satellite image maps for the entire country as base for decentralized planning, where high resolution data is ortho corrected and it is available in true color, so that at grassroots level people can easily interpret the data in the planning purpose. So, there are a number of value added products also are available for planning. Now, the second objective is to prepare thematic and base layers on 1:10,000 scale using satellite images and also georeferencing and vectorization of the cadastral maps, which can be superimposed on the satellite data to identify the target groups and other thematic information like present land use land cover, drainage, water bodies, infrastructure and settlements, particularly the spread of the settlements, and another important derived thematic information like slope classes from terrain models, which will be useful in planning purpose, particularly in soil and water conservation and developmental plans. To develop a comprehensive web portal as Panchayat Raj and stakeholders requirements for decentralized planning and governance. Now, this is required today because already internet has penetrated quite up to village level. So, outreach to citizens and data dissemination becomes much easier through an web portal. Then the last one is to build capacity of Panchayat Raj institutions and all the stakeholders for the use of this space based information in decentralized planning and governance. So essentially what I mean is, this particular project called SysDeep has three verticals. One is creating a good database from the satellite as a primary input and an enabling environment to process this data, and an outreach mechanism through web portal to reach out this database to different people. Essentially, coming back to Bhuvan Panchayat portal, now you all are aware internet connectivity is expanding leaps and bounds, and the priority of the government is also towards that, and mobile phone penetration is also there in the rural areas. So, this particular project envisages using this instrument and collect the information that is required for planning purposes. So, Bhuvan Panchayat essentially has a platform called Bhuvan Panchayat, which has been designed and developed for digital empowerment of the Panchayat planning and governance. It provides, besides data, enabling an environment for asset mapping. Now, when I say asset mapping, this includes governance as financial requirements like primary health centers, your primary schools, ATMs, seed discussion or stock of anything at Gram Panchayat level. All these assets are taken, and there is an activity planning done based on the government programs, and implementation and monitoring of these activities can also be done on this on this portal, and interactive report generation also is possible at panchayat level. Now, this whole thing can be accessed by anyone who has an internet connectivity. The website is www.bhuvan-panchayat.nrsa.gov.in, so that the citizens in general and the 3 tiers of Panchayat Raj institutions in particularly are the potential users of this portal. It also offers multilingual user face, because we know that at Gram Panchayat levels across the country, lot of local languages are used. So, we have actually provided multilingual user interface, so that it becomes very difficult, very easy rather for the Gram Panchayat grassroots level workers to work. So, users can register either as citizens or as panchayat, block or district level workers, get into the system, and the administrative privileges are also given according to their status, whether they are citizens or PRIs, and one can actually process the data in a following way. So, essentially from this there are about 6 modules. One is for geo-visualization of the entire database at village levels, then generation of area profile reports which can be generated and downloaded, then asset mapping through mobile applications, and integration of the already geotagged assets available, then activity planning under centrally sponsored and state schemes, then implementation of monitoring of planned activities and downloading maps and reports of selected areas of interest by Gram Panchayats. So, this particular project today is successfully implemented. There are a lot of case studies using this particular database, and to further enhance the utility of database created under SysDip, a spin-off project is also implemented called ePris, that is essentially to empower Panchayat Raj institutions in using SysDip database. So, here again the 3 objectives are capacity building of all the Panchayat Raj institutions, line departments, academia and NGOs, which provides lot of employment opportunities for the citizens around. Then asset mapping of 10% of the Gram Panchayats and activity planning of 10% of the Gram Panchayats. And a number of case studies have come out of this study, where we have done typically a gap analysis, proximity analysis and a number of planning products which will be useful at Gram Panchayats in preparing local developmental plans. So, this is what I wanted to share, and there is going to be a demonstration of Bhuvan Panchayat also in detail. Thank you.
Remote Sensing Day is celebrated honoring birthday of Dr. Vikram Sarabhai, a visionary, popularly known as father of Indian space program. Thanks to Indian Society of Remote Sensing for taking this initiative of popularizing geospatial technology across India. Thanks are also due to ISRS for including my talk on use of geospatial technology in Northeastern region. Northeastern region is a complex having a highest forest cover area, abundance of natural resources, rich biodiversity, but associated with 2/3 of hilly terrain, varying altitude from sea level to above 7,000 meters, highest rainfall area, high seismic activity active zone, floods and landslide, etc. In addition to more than 98% of international border associated with geopolitical complex environment. There are many other challenges: poor communication linkages, weak information base on different thematic areas, lack of technology diffusion, limited utilization of geospatial technology for development of northeastern region. So what are the areas where geospatial technology can be used for northeastern region? Natural resource management, disaster management and emergency response, vector-borne diseases and health GIS, education, telemedicine, infrastructure development, urban and regional planning, asset mapping and local level planning, weather services, forecasting, early warning, geo-web services in planning and development. Realizing the needs of northeastern region, Department of Space has established the Northeastern Space Application Center in 2000 jointly with Northeastern Council to address the use of space technology for Northeast. Accordingly, taken up many application areas like natural resource management, developmental planning, disaster risk reduction, satellite communication for societal applications, space and atmospheric science activities, academic interface, and capacity building to expand the use of space technology. Space technology plays important role in forest working plan preparation by providing information like forest type, forest density. The work is being carried out for 5 states of northeastern region. There are many challenges in forestry applications like monitoring of forest changes, use of technology inputs like LIDAR, microwave and hyperspectral remote sensing, etc. Agriculture is important for northeastern region. Considering the limited land for agriculture, pilot studies have been done for crop acreage, damage assessment, soil and land evaluation. Challenges are acreage assessment for whole northeast for agriculture and horticulture crops. Due to small land holdings, we have to see how space technology will support for crop insurance, marketing. Maybe UAV will be able to help. Of course, capacity building is essential requirement. Sericulture development initiated to map potential areas suitable for silkworm, host plants of mulberry, erry, tusser and moga, and help in expanding the areas under sericulture funded by Central Silk Board. Silk's web portal is created and made available for use. State sericulture departments may use the portal to expand the sericulture activity with the support of Silk portal. Space and atmospheric research facility is established to understand the atmospheric process prevalent over the region through observation and modeling for studying aerosol radiative forcing, boundary layer, trace gas, chemistry, transport modeling, etc. Long-standing requirement of polarimetric Doppler weather radar has been realized, jointly developed by ISRO and Bharat Electronics Limited in collaboration with NESAC and Indian Meteorological Department Regional Office, Guwahati. This facility is dedicated to the nation by Honorable Prime Minister of India in 2016. It will provide improved weather services in northeastern region. This data is made available to promote research in the areas of monsoon dynamics, cloud physics, thunderstorm and hailstorm, etc. Considering the inaccessibility and difficult terrain conditions, tele-education and telemedicine will benefit the region. Tele-education is being revived with 350 SIT VSAT terminals with a dual interactivity for all the state of Northeast region. It will be fully operational by the 4th quarter of 2017 and it is fully funded by Department of Space. Efforts are being made taking support of NEC to revive the telemedicine facility in the near future to expand the connectivity through inexpensive ROTs. Flood is very critical and damage large properties and loss of life every year, particularly for the major parts of Brahmaputra and Barak basins. Flood early warning system is implemented successfully for Assam Disaster Management Authority since 2012. Early warning of 12 to 36 hours in advance is given. Accuracy ranges from 70 to 90%. It is being extended to flood prone areas of other states of northeastern region. Almost whole northeast is prone to forest fires. The instances of forest fires are uploaded with additional information of GIS layers and proximity studies and inform the forest authorities to prevent and or stop the further spread of the fires. EIV system integration and application is a unique area of study taken up by Northeastern Space Application Center. The facility is expanded to all the states of Northeast, sponsored by Northeast Council. All the state remote sensing centers are provided with EIVs along with the softwares. Extensive training is also provided to all of them. EIVs are used extensively for variety of applications, mainly with very high spatial resolution and very good vertical accuracy, addressing large number of application requirements. Whatever is done will be of no use if the information generated is not made available to all the concerned, particularly for the decision makers. Taking this point in view, NESAC has developed Geo Web Portal, that is NEDRP, Northeastern District Resource Plan for all the districts of Northeastern region. Based on specific requests, few customized services are also provided, like election GIS, forest GIS, census GIS, and geotourism, etc. Mobile apps are also provided for collection of field data and upload to the portal for visualization and analysis. Ministry of Donor and Northeastern Council wanted to monitor implementation of certain sponsored schemes of Northeastern region. NESAC is helping in creation of management information system, geospatial web portal, enabling them with geointelligence. What are all the challenges for Northeastern region? So many challenges in the Northeastern region due to its complex terrain, persistent cloud conditions, zooming, marginal farmlands, cultivation in valleys and sloping terrains inside the forest lands, limited water resources during dry conditions, etc. In summary and way forward, NESAC playing an important role in use geospatial technology for natural resources, meteorology, space sciences, satellite communication for societal benefits, and disaster risk reduction for floods, forest fires and landslides, etc. Expanded the capacity building and outreach activity for Northeastern region, establishing linkages with all the state application centers, central organizations, research institutions, and academia for operational service of research with focus on development of Northeastern region. Thank you.
Bhuvan is ISRO's web geospatial portal. Now, when we say web geospatial portal, it means it is available on the internet, it is available for everybody, and it talks about the geographical information in terms of satellite images, in terms of maps, in terms of the locational information or locational intelligence services. So, one of the major component in that is the crowdsourcing. The crowdsourcing means we get lot of information from the users of the Bhuvan, and this information is provided through various mobile applications as well as from the web applications. Bhuvan is mostly used for almost we can say 7 category of applications. One is it's a visualization platform which tells you about allow you to visualize multiple satellite images of the various dates and multiple resolutions. It gives you information, lot of information about the foundations of the information on the maps. It talks about the developing web applications, developing mobile applications. It provides the platform for sharing the data to the states and create a new mobile application from that data along with the Bhuvan applications. And Bhuvan provides the support for the disaster management. Apart from that, a national level mapping projects which has been carried out by the ISRO, all are disseminated through a Bhuvan platform. And the National Information System for Environment and Climate Sciences, NICES, output products are also disseminated.
Indian Geospatial Platform Bhuvan can be reached through Bhuvan www.nrsa.gov.in. This portal can also be reached through ISRO main web portal, NRSA main web portal. On the main screen of Bhuvan web portal, you will be able to see various applications that caters to 2D, 3D, satellite data download, disaster services, as well as space specific portals and geo-governance portals. As a sample, here you can see the glimpse of Bhuvan portal. The icons depicting 2D, 3D, open data archive, climate and environment, thematic services, disaster services, ocean services, and create a map and GIS. These are specifically catered for public viewing. Similarly, we are having government and central minister portals like environment, forest, NVIS, CRIs, CLATCHES, island information, school Bhuvan, and extra. Similarly, application sectors that are covered by Bhuvan are agriculture, forestry, e-governance, water, tourism, urban, rural, tourism GS, and archaeology. Primarily, Bhuvan 2D will have the provision for displaying map data as well as satellite data. And basically, the satellite data will have provision of scale-based rendering of data. At India level, you will be able to see course level satellite data, and assume if we are coming to state level, satellite data of the order 56 meters will be visible, and similarly if we zoom in, we will be able to see higher resolution data. That facility exists in the Bhuvan web portal. Similarly, Bhuvan 3D is also available. The difference from 2D and 3D is we will be having 6 degrees of freedom, not only on x direction and y direction like 2D. In 3D, we will be having the facility of panning also. As an example, you can see I am able to zoom up to a reservoir level, and I will able to do the tilt operations in this fashion. We are having free satellite data download area called Bhuvan Noida, NRSA, ISRO Open Data and Product Archive facility, where we will able to download satellite data, team products, and project specific data download. As an example, in the area of satellite and sensor section, we will be able to download digital elevation model that are generated from Cartosat, similarly HiSci, OceanSat, Scatterometer, AWIFS, and LIS3 data. As an example, let me show this AWIFS data downloading, where we will able to select the required tiles, and we can start the downloading. So, particular tile will be having multi-date data. So, user whoever is interested, he can download that particular tile. In the same fashion, we will be having ocean products, atmosphere products also, where user can download under the NICES program. As an example, under the terrestrial products, we will able to download geophysical products, hydrological products, and land cover products and allied products. Similarly, these disaster services or NDM public services, we will able to put all the data that concerns to cyclones, drought, earthquake, flood, forest fire, and landslides.
Since the release of Bhuvan in 2009, we have taken several steps to bring out a various citizen-centric application. On September 7th, 2015, Honorable Prime Minister has taken a ISRO national meet. During that meet, we got the opportunity to bring out collaborate with various central and state ministry to bring out various societal application. And as on date, we have around 70 plus application, and all those applications are listed out under the governance thing, and you can see that watershed, urban frame survey, postal application, archaeological survey of India, like that all these things are placed in this particular portal. And here one such application I will take it. The Department of Post, we have collaborated, and we have given a Android application where the postman himself or herself has geotagged all the post office's location, and they have attached with all the facilities what they are providing from that particular post office. And once the postal data has been uploaded into Bhuvan, and what we have done is we have brought out a citizen-centric application on that. So, if any user or if any person go to any new place, they can search nearby post office and they can identify that what kind of services they are offering and what is the timing and all the things they will get it. For example, right now what I have done, I have taken a Sanat Nagar colony post offices, and once the search is performed, it is listing out that all the post offices having the similar pin code, and it is coming here. On click of that one, you can see that, so this is the post office and this is offering that mail product, insurance, speed post and parcel, and certain facilities which is not available like express parcel and media post. If the user want to find out, okay, which is the nearby post office supporting express parcel, and they can refine their search and they can land into that particular place. And it is not only showing the services offered, it will also give you the photograph of that particular place, so that they can easily identify that location physically. And it is not also identifying, and we are also providing the routing application where user can select the destination and they can navigate from the current location to the nearby post office. And similarly, everyone knows very well about this 100 days or 150 days employment scheme, the Mahatma Gandhi National Rural Employment Guarantee Act. Under that act, we are having a target of 3.6 crore assets have to be geotagged. And as on date, if you see that around 2 crore assets are geotagged, and all the assets, 2 crore assets, we are facilitating the Gram Panchayat level people to upload the data into Bhuvan. And here you can see that we have a filter to do the state level and district level, and you can also filter up to the block level. So this is one such example from Telangana, and district Mechal and block is Gatkesar. And you can see that this is one particular road where the development of land for the weaker section which has been given, and all the attributes is linked in this one. And here the very important thing is the geotagged information is coming from field, and it is linked to Bhuvan. And again, this particular asset ID, whatever the unique ID is there, it is again linked back to the MIS data of NIC, so that online all the data sets are getting fused and the data is available for the moderator. And once it is moderated, the physical progress is again monitored here. Again, it is also linked back to the financial progress of that particular data. And the similar way, we have also collaborated with the National Monument Authority, where the different archaeological sites are geotagged, and along with that one, the high resolution satellite data from Cartosat series have been taken, and the monument boundary has been taken. Apart from that monument boundary, we have a protected area, prohibited area and regulated boundaries. So here again one more citizen centric mobile application has been developed. Any user, if they want to go for any construction activity or any activity, they can take a location and they can uplink it to Bhuvan. It will immediately, it will intersect with the protected area, prohibited area and regulated boundary, and it will create an image chip, and the image chip will be again sent back to the mobile. So now you can see that right now I have taken Delhi, and Delhi mini circle is the circle, and Jantar Mantar has been taken, and you can see that this red color is the protected area, and yellow color is the prohibited boundary, and green is the regulated boundary. If any person wants to have any particular activity, they can send it, and immediately the image chip, whatever you are seeing here in the window, it will be created and it will be given to the mobile. And from there again they can go for a further regularization activity and other things. And the similar line, there is another very famous scheme, you know it, it is Pradhan Mantri Awas Yojana, where the scheme is giving a benefit for the weaker section to go for a construction activity. And here one example I have taken in the state of Tamil Nadu and Salem district, and here you can see that these are all the cluster of houses which has been given for a beneficiary, which has given for allotted under this particular scheme. And here it is not a one-time geotagging. The various stages of construction of your houses has to be geotagged, because the physical progress will be again linked to the financial progress. Accordingly, the finance will be credited to the beneficiary account. And here you can see that one such example is like the beneficiary name is Devanayaki. And here you can see that it is in the lintel stage. And then whatever the next stages are there, it will be also linked here, and the benefit will be credited to the user account based on the physical progress.
One of the major feature of Bhuvan is to show the multi-date satellite images. It means that area of the same area can be shown at multiple dates. You can see the this calendar I have put it on now, and these dates 1965, 1973 to onwards, satellite images are available at these places, and as I go on zooming at any particular point, these number of dates will be go on changing. It means at these dates the satellite images are available on Bhuvan and change monitoring can be done. As an example, if I see, we can go to the kind of Mumbai, we know that there is a sea link available from Bandra to Mumbai, and this is the image what I am showing is of 2009 and 10 time frame, wherein you can see the sea link was under progress and there was some lot of breaks available here. But if I see the images after 2014 onwards, we can see the entire sea link is built up. So, this is one kind of example. Another example is like a terminal 2 Mumbai airport, we can see that this is the satellite image of 2015, and if we see the satellite image of 2010, if I put it on now 2010, you can see the satellite, this terminal was not at all available and it was under construction. So, such kind of images changes helps in providing the change monitoring options on Bhuvan. Similarly, number of satellite images that have been now pumped on Bhuvan for multiple resolutions. Now, we also get the entire India 1 meter satellite resolution, and you can see the part of the Gujarat here, wherein number of plantations are available at these places, and practically you can go to the count the number of trees in a kind of cadastral maps or cadastral surveys. So, such kind of potential has been provided. So, when we go to similarly, these images can also see into 3-dimensional view. We can see the Dome reservoir in Maharashtra, this is the Dome reservation in Maharashtra, and you can see the hilly terrain here. And if we literally kind of do similar visual analysis, we can see that there is an agriculture area at the bottom of this hill, and a lot of gullies available, and a number of planning steps can be taken up. You can see the this is the gully showing that the when the rainfall occurs, the water flows from this line, a gully plugging activity can be carried out at this particular place. So, these show the potential of Bhuvan for carrying out the development activities even without doing much of the analytics to be done. Now, similar kind of thing, when we take off such area, we can get the terrain profile by tools provided on the Bhuvan. I can go to the terrain profile here and simply draw a starting and the ending point and say the shore and terrain profile. So, this gives me the variation which has happened in the terrain. So, this is a valley here, and then we are going to the hill which is shown by this particular point, then there again the valley, there is a hill which is shown by this particular point, and like this. So, one can get the cross section of a terrain showing the various undulations.
Bhuvan Panchayat portal is an ecosystem of Bhuvan for Gram Panchayat development and decentralized planning process. Bhuvan Panchayat portal can be accessed using the URL bhuvan-panchayat.nrse.gov.in. So, this is the portal, and the portal comprises of two major components. Number one, the geospatial data sets generated under SISTP project for decentralized planning. Number two, the salient features carrying out the decentralized planning process. Let us go in detail about the first component, that is geospatial data sets. In this portal, we have got satellite imagery of 2.5 meter resolution, which is for entire country. Apart from that, we have administrative boundaries starting from state, district, block, panchayat, and we also have cadastral maps for 5 states: Kerala, Haryana, Telangana, Assam and Andhra Pradesh. And we also have thematic data sets which are generated under SISTP projects, comprising of drainage and water bodies and canal, land use land cover map, slope maps, infrastructure maps. So, let us go to get more insights on this viewer and the data sets available in this portal. So, we have the state boundary and progressing towards the district boundary and progressing towards the block boundary, and we also can visualize the Gram Panchayat boundaries. Now, coming to the second component in detail, that is area profile report generation, asset mapping and activity planning. So, let us select one area in Rajasthan state. Jodhpur district, Luni block, Dawa Gram Panchayat. So, here we have navigated to Dawa Gram Panchayat of Jodhpur district, trying to visualize the drainage data, and we can also in similar way visualize the land use land cover data. Land cover data, Land use describes about the usage, that is how a piece of land is used by a common man, and land cover describes how a piece of land is covered by various aspects, for example, forest cover, scrubland, etc. So, here we are getting insights about land use and land cover of this Gram Panchayat Dawa. We can see here the red corresponds to the built up area, and we also have scrub land open, and we have grassland and grassing land under land cover. When we talk about Rajasthan, we have to mention about the sandy areas and the sand dunes. So, here we can see the important land cover aspect of Barmer district, which is sand dunes. Now, coming to next important aspect, that is area profile report. So, apart from the spatial data, the team has also put forward brilliant efforts to collect the socio-economic data and demographic data. So, here we have options to identify the geographical details of this particular Gram Panchayat. We have selected here Ampala Gram Panchayat under Telangana state, and we have provision here to update the major issues and constraints of that particular area, similarly priorities, and then we also have the total census data integrated with this portal. So, what is the outcome of this beautiful effort? We can generate the complete PDF report which is providing the insight of this particular Gram Panchayat Ambala, starting from the geographical details up to the vulnerable areas. So, this is an output of this particular dynamic area profile report generation module. So, let us have a deep look at the particular contents of this particular PDF file. So, coming to the next major important module, that is asset mapping. So, when we plan for the development of a Gram Panchayat, we also have to know or have awareness about the community assets available in this GP. So, we have developed a mobile application in which will work in Android platform, and this particular mobile application can be downloaded from the portal, and the registered users can upload the Gram Panchayat assets, thus creating the Gram Panchayat assets inventory. So, here we can see an example of Gram Panchayats mapped under Ampala Gram Panchayat. So, the total assets mapped are listed here. There are different 25 type of assets. We are seeing an example of secondary school geotagged, and shall we see the details of the secondary school? Yes, we have the photograph, latitude, longitude. Apart from that, it also describes about the ownership and the number of students and other sanitation and hygienic condition of the school over here. So, coming to the last important aspect of Bhuvan Panchayat portal, that is activity planning module. Here, the entire workflow of a decentralized planning, starting from creating a plan and then consolidating a plan and then getting approval and other aspects are integrated in this particular portal. We can see there are 17 flagship programs available here. For example, let us consider Mahatma Gandhi National Rural Employment Guarantee Scheme. Under that, if one particular Gram Panchayat is interested in creating construction of the Anganwadi centers, yes, we have a provision to select a particular scheme or activity, and we can mention here which is the spatial location in which these particular aspects can be constructed. So, to enable the participatory approach, we have also included the citizen-centric tier, that is the tier which will propose the plan, and the respective Panchayat Raj institution representatives will be consolidating and approving the particular plan. So, after the particular plan is approved, we also have the mechanism to monitor the implementation activities of these particular various schemes. Yes, we also value the feedback of the users. Right now, we have around 3 lakhs plus visitors of this portal and around 25,000 various type of downloads and around 50,000 registered users for this portal. If you wish to provide feedback for improving the portal, we can use this share view options and provide the feedback. Thank you.
So, by looking at these various applications that has been demonstrated by Bhuvan for ministries and states and various users, it is very well clearly understood now that Bhuvan is open to all. It also provides specific applications with the role based access, and this kind of portal it is being utilized by the people in a large amount of applications. Specifically, if to tell the statistics, if I say almost like 7 lakh visitors uniquely visit Bhuvan every month, and there is something like 6.8 lakhs download which has happened on the Bhuvan. Last year itself, if you see, there is something like 4.5 million pixels have been processed for the various images to be showcased on Bhuvan. The largely the data which is showcased on Bhuvan is of high resolution, which is 1 meter data, and it covers entire India, 32.87 lakhs of square kilometer, and this data is available for the multiple time frames. This kind of data provides application potential for large number of sectors. So, this is the kind of data which is useful, and this is taking Bhuvan to the users, wherein now Bhuvan Alexa rank, which is a kind of indicator for the popularity, has increased by 400% in last 3 years. This is the impact which Bhuvan is making on the user community.
VIDAS is an acronym for Visualization of Earth Observation Data and Archival System. It is a repository and information dissemination system for various applications carried out using satellite data. VIDAS is a geovisualization tool which also enables data analysis on web, and it also caters to various applications in the field of agriculture, forestry, new and renewable energy, hydrology, urban planning, etc. One can access this website at https://vidas.sec.gov.in. Now we will have a demonstration of VIDAS. This is the home page of VIDAS, and we have various atlases available on it which are generated by various application scientists. Also, if we go to the Earth observation, we have various information like, for example, snow and glaciers. So we add glacier morphology, lakes, snouts. So we can add all this information onto the image, and this data can be seen on satellite data in the background. As you see, all the glaciers of the country from Karakoram Range to Arunachal Pradesh. This can also be visualized in 3D environment. We click at 3D mode and it will go to a 3D environment. So these are the glaciers in 3D. So you can see all glaciers in the 3D. This digital elevation model has been generated using Cartodem. You can switch on, switch off the layers. Then we have vegetation monitoring. So here multi-temporal satellite data like OCM and any other satellite data and DVI images every 15 days are available for the last 5 years, 10 years, 15 years, and we can analyze the data. So here when we click at any point, we get the profile of any pixel over the period. We can compare it with different years and we can know the growth of the vegetation on that pixel. So a comparative study can be done at any pixel location on the country. Then we can compare the two dates and we can get the difference of image. So here on the left hand side we have image of 2017, on the right hand side we have image of 2016. So here on the third image we can live get the difference between the two. So the green color shows the area where vegetation has improved, and the yellow and red color shows the vegetation has degraded. So we can know the condition of the vegetation as well as crop between the 2 years. So a live difference between the two images is possible on VIDAS. Similarly, we can do classification on VIDAS. If you have a multi-temporal satellite data, then using the temporal profile, once we can click our training site, and then based on the temporal profile, it will classify the image. So this temporal based classification is also available on VIDAS. Now as you see, I am clicking these 3 points and generating the mask. So this mask is generated and I can classify an image based on multi-temporal data. Then we have new and renewable energy section. where information about solar energy, wind energy and wave energy is available. For example, right now what you see is a solar potential image of the country calculated for last 4 years. It is an average, and you can see all the solar research stations available in the country. So clicking at any point gives the potential at that point. So here, for example, the potential is 1661 kilowatt hour per meter square. So this type of information is available. There is a solar calculator which calculates various other information. For example, for this latitude, longitude, I am getting average minimum temperature, maximum temperature, tilt angle of the solar panel, annual global insolation, and monthly information from 2011 to 16 is also shown here. We can get this in the graphical form, and also the sun path, the azimuth elevation angle, as well as any obstruction due to any mountains or any other obstructions can also be seen on this image. Also, we get the day length over the period. Similarly, we have on wind related information like speed of the wind, direction of the wind is available on monthly basis. So user can click on at any point and he can get the wind speed as well as direction at any point. So, and similarly, using a wind calculator, monthly profiles of wind, average wind direction is also available at any point. This wind profile has been generated using scatterometer data, and the wind profiles over land has been generated using WRF model. Similarly, we have wave information where wave heights, monthly wave heights are also available. So this is the wave height at any point. So wherever the significant wave height is there at any point can also be obtained. Then we have an urban information system where small, medium as well as large towns of the country, we have a urban growth model which shows how the growth is there in the cities over the last few years, and also the prediction in the coming years using sleuth model. So this type of information is generated for various cities of Gujarat, and this information system provides the prediction of the urban sprawl in this area. Vedas also provides infrastructure to researchers in terms of hardware, software, satellite data, thematic information to carry out research using this wealth of information available at this center. Vedas is a tool for disseminating the information generated by research and development of the scientists, which can be used by a common man. Thank you.
Good afternoon. As Secretary of Indian Society of Remote Sensing, I would like to welcome all our participants and dignitaries from ISRS local chapter, different ISRO centers, IRS distance learning program, user state and central government departments, academicians, ladies and gentlemen. My heartiest greetings to all of you on the eve of National Remote Sensing Day. I will briefly tell you about Indian Bioresource Information Network portal, commonly known as IBIN portal, with URL www.ibin.gov.in, which is hosted from Indian Institute of Remote Sensing. IBIN portal provides data and services related to bioresource and biodiversity in the country. The genesis behind IBIN portal is, as you know, inventorizing and assessment of bioresources is a big task for the large country like India. Several organizations are involved in generating repositories of unique and diverse datasets on countries' bioresource and biodiversity. But datasets are scattered and are not easily accessible for an integrated analysis. If these datasets from diverse themes and geographical areas are seamlessly integrated, we get new perspective and ideas to take informed decisions. With this motive, IBIN was conceived in 2006 by the Department of Biotechnology, Government of India, in collaboration with Department of Space and University of Agriculture Sciences, Bengaluru. It is a single digital window platform that brings together all the distributed bioresource databases of the country using principle of spatial data infrastructure. Its major goal is to network and promote an open-ended co-evolutionary growth among all the digital databases related to biological resources of the country and to add value to the databases by integration. IBIN portal services for data on Indian bioresource includes plant, animal, marine, spatial distribution and microbial resources. Presently, there are two core nodes of IRS with spatial data services and US Bengaluru with species data. There are 5 federally distributed organizations which are contributed to the IBIN portal and they are commonly called as Bioresource Information Centers. They are ATRI from Bengaluru, FRLHT from Bengaluru, Calcutta University from Kolkata, IHPT Palampur and Northeastern Hill University, Shillong. The portal was launched by Honorable Scientist Professor M.S. Swaminathan on October 12, 2012 during the Conference of Parties meeting at Hyderabad. The unique features of IBIN are following: species search, species overlay on map services, field guides using multi-criteria decision making, IBIN standards which have been created uniquely to cater all the global standards for species design as well as interoperability. One unique feature which has been added into IBIN is species distribution modeling using Maxent model. We are also working on one of the most important applications that is called crowdsourcing, wherein we are using a citizen science approach for species data collection. And in the coming months, IBIN will be linked with Bhuvan interface to access thematic services which are available in the portal. Now I would like to take you to the IBIN portal, which looks like this. You can directly access the IBIN portal through ibin.gov.in, wherein you will find 4 major categories, which is biodiversity, bioresources, conservation and toolkits. You will find around 326 species database is available in this portal. There are around 13,051 maps available. There are 154 chemicals and 11 checklists. Now I will browse to different applications which are available in the portal. The first thing is you can directly do species search by clicking on the species button. The moment you go to this application, you can do the searching on the basis of scientific name or common name. So let us put one search of one of the species, which is Punica granatum, which you can find it over here also. So you can directly click to that species. You will find n number of elements which are associated to this, and these elements have been derived from IBIN standards. So these standards are basically taken from the elements of the global standards like Darwin or SPM, or there are so many other standards which are available. So there are the features which are available under species search are biogeographical zones. You can see that this data is coming from US Bangalore. The same distribution is also shared through FRLHT Bengaluru. There are references, there are medicinal parts, there are medicinal actions, soil properties, and there are some other information like pharmacology, journal morphology. All those elements are available, habit and habitat. So you can browse this entire elements for every species. So there are some other tabs also given like multimedia. You can see that so many different photographs are available of the same species. You can go to one of the most important information is ancient knowledge, where you can get the description about its historical existence. Like you can even listen shloka.
पनसाशोककदली जम्बूलकुचदाडिमाः द्राक्षापालीवताश्चैव बीजपूरातिमुक्तकाः.
Similarly, you will have description related to other properties, and there are so many shlokas which are linked to the individual species. Now you can go directly to the main portal, and then now you can overlay the species on maps. So here you can browse different species name, like I am giving Acacia tomentosa. You can search this species. After searching, you can find the details. That is, all these details are related to the species characteristic. Then you can also provide the attribution. Now, from where this data is coming? This data is coming from US, Bangalore. And then the moment you give to add to map, you are able to find the species distribution, the geographical species distribution. And then you can even overlay your existing map services like vegetation type, you can disturbance index, as well as biological richness, which are the derivatives of the biodiversity characterization at landscape level program of Department of Biotechnology and Department of Space. Now you can go back to the IBIN portal. The another application which is important is chemical. You can even see the chemical composition of different uracolic acid, vincristine. These are different chemical compositions. If you happen to go to any of one of them, you can see what all information is available, like derived chemicals, details, and also in which species this particular chemical is found. So all those things you can access depending upon your requirement. Another important application is field guide. Now here there are three types of field guide which are already available. One is on the butterfly, and remaining is related to some of the plant species. So if you go to butterfly, there you can see that if you happen to see a butterfly in your garden, you will be able to identify it by making use of this field guide. If you apply the condition on the basis of antenna, you can directly give, like I can go an option of antenna with rings. You will find 28 butterflies with the similar characteristics, and then you put on the basis of color. If you happen to write blue, then automatically your search have been narrowed down to 5 butterfly which are having blue color. Then if you happen to put a ventral color as well, you will see that you will write again blue. Then you are left with only 2 butterflies which are fulfilling your requirement. And then wing pattern, and when you put a wing pattern present, then automatically you will narrow down to a single butterfly which is called al peacock royal, and you can see different characteristics of that particular butterfly, that is what is their host plant, what is the seasonality, all this information can directly be seen. So this is the way you can use this field guide for different identification. Now I would like to tell you about one of the important application which has been built recently is species distribution modeling, wherein we are using already well-known model that is called Maxent. And here what you can do is you can directly provide the presence location of your species, and there you can use this choose file option where you can upload the CSV file. So you can see that how you can upload this CSV file. So the moment you upload this CSV file, window has to be adjusted as per your study area. So once this window has been adjusted, automatically the coordinates will go into the boxes. And once these boxes are available, you can directly go for 15 bioclimatic variables which can be used for species distribution modeling. Here there are certain checkboxes. You can give which variable you want to use it for distribution modeling. So once you do that, you can directly apply a check button, and once you check it, you can finalize your output, and this output is available with you. Now the moment you have this characteristic, the jackknife information can also be derived from the existing database, and you can see that all the information is now available with you, and you can open this HTML files and you can see the analysis of omission and commission and decide which layer is sensitive to your species location. So once this data is ready with you, you can directly download this entire information and you can make use of this information to do analysis as well as generate important information which can be used for species distribution. Now I would like to show you another important application which is in process and will be available to you shortly through IBIN portal, that is IBIN mobile app, which is called as citizen-centric application. Now here you can provide the following information, that is the user, the email ID as well as the location. Once this is given, you directly go to the record location, and from the record location you can directly take the coordinates, and after that you have to select the type on which your record is based, whether it is photo, observation or collected living organism or specimen. Once this is given, you can provide the information of that particular species, that is species scientific name, common name, synonym, habitat and location. Once all this information is given, you have to provide the conservation status of the species, like we can provide Indian or global. So once that is done, you can upload this entire information on to the map server of the IBIN. So the moment you capture the photo, you are able to see the entire information of that particular species which you have uploaded. Once you are done with this information, you are able to see the entire details which you have captured. And after that, you can directly submit this information and it will go to the server. And from the server, you can see the location. The only important thing in this application is this entire information which goes into the crowdsourced data has to be curated. So we are identifying the team of experts which will be doing the data quality test of this information. So these are some of the glimpses of the IBIN portal. I would also like to tell you that this portal has been designed and developed using open source technology like OpenLayer, GeoServer, Apache, PHP, PostgreSQL, Red Hat, wherein Linux operating system of CentOS version 7 has been used, and also we are using R libraries with Dismo and Maxent species distribution model for implementation. In the end, I would like to conclude that IBIN portal will be used for serving relevant information on bioresources of the country to the professionals involved in bioprospecting, marketing, protecting biopiracy and the conservation of bioresources. Thank you very much.